When we look up at Saturn, it's usually the rings that grab us. But orbiting right there is Titan. It's Saturn's biggest moon. And, well, it's this incredibly weird place.
Yeah, it's got this thick, hazy atmosphere, mostly nitrogen like ours, believe it or not.
And clouds, even rain. But it's definitely not Earth.
Not at all. And that brings us to today's deep dive. There's been this really remarkable discovery, the first time we've directly seen cloud convection happening up in Titan's northern hemisphere.
Okay, convection, like storm clouds building up.
Sort of, yeah. But happening near its huge methane lakes.
Methane lakes, right, not water.
Exactly. And seeing this convection there, it's a huge piece of the puzzle for understanding Titan's climate. It's this really active methane cycle shaping the whole moon.
So it's about understanding weather on another world.
Precisely. And comparing it, seeing how these processes work differently elsewhere, it tells us a lot about planetary atmospheres in general. And yeah, we need some serious hardware for this.
Like the Keck Observatory. And Webb?
Absolutely. Keck and the James Webb Space Telescope were critical. Their power, their ability to see in specific ways, that's what made this possible.
Okay, let's unpack that. This convection, you said it's the first time seeing it in the north. What did we know before? Did we think the north was quiet?
Well, not exactly quiet, but most of the strong evidence we had for this kind of vertical cloud movement, this convection, was from Titan's southern hemisphere. Finding it definitively in the north is a big deal because that's where the really massive methane seas and lakes are. We're talking like a combined surface area comparable to the Great Lakes here on Earth.
Wow, so seeing weather bubbling up right over that massive methane source.
Exactly. It tells you a lot about where the atmospheric action is coming from, how the system is fueled.
And you mentioned Keck, the observatory up on Mauna Kea in Hawaii. What makes it so good for spotting this sort of thing on Titan?
Right. Keck's location, high up, stable air, plus its advanced tech, especially adaptive optics, gives it incredibly sharp vision, even looking at something as far away and hazy as Titan.
Adaptive optics. That's the tech that corrects for the Earth's blurry atmosphere.
Yeah, it gives you a much clearer view. Dr. Connor Nixon at NASA Goddard, he was involved in this research. He put it really well.
What did he say?
He said something like, thanks to Keck's precision, they actually watched methane clouds evolving near the North Pole, right where the Cassini spacecraft, years ago, found those giant lakes.
So connecting the clouds directly to the lakes?
Yes. And he pointed out this helps us link cloud formation to, well, methane rainfall, which then refills the lakes. It shows that whole cycle working,
That cycle. It's still amazing to think it's methane, not water. You said Titan's weather is Earth-like, but alien. Can you elaborate on that a bit more?
Sure. The basic setup is similar in a way. Both have atmospheres dominated by nitrogen, both have clouds, both have precipitation.
Okay.
But the liquid is the key difference. Earth runs on water evaporation, clouds, rain, snow, ice. Titan does the same dance, but with methane.
So methane evaporates from those lakes?
Exactly.
Yeah.
Rises up, forms clouds in that super cold atmosphere, maybe minus 180 degrees Celsius, something like that.
Freezing.
Oh, yeah. And then sometimes it falls back down as this, well, people describe it as oily methane rain.
Oily methane rain onto a surface of water ice that's as hard as rock.
You got it. It really paints a picture, doesn't it?
Yeah.
Nixon actually said Titan is the only other place we know of with this kind of Earth-like weather cycle, just with different stuff.
It really drives home how unique it is. So how did they see the convection? What was the actual evidence in the observations?
Okay, so the teams were observing back in November 2022 and then again in July 2023, using both Keck and JWST.
Right.
What they saw were changes, like dynamic shifts in the cloud formations, particularly at mid and high northern latitudes. The key thing was evidence that cloud cells were moving upwards, gaining altitude over several days.
So they could track them actually rising.
Yes, that upward movement is the classic signature of convection. Think of like warmer, more buoyant gas rising through cooler surroundings. It's the same basic physics as a thunderhead forming on Earth, just with methane vapor instead of water vapor.
But how do you even see that detail through Titan's haze? It always looks like this fuzzy orange ball in pictures.
Yeah, that haze is a real challenge in visible light. It scatters everything. That's where infrared light comes in.
Okay.
Mauna Kea's altitude helps. Less atmosphere to look through.
Yeah.
But Keck's adaptive optics are crucial, like we said. And they use specific infrared filters.
Filters, like putting different colored glasses on the telescope?
Sort of, yeah. Different infrared wavelengths penetrate the atmosphere to different depths. So using Keck's NIRC2 instrument with these filters let them probe various layers.
I see. Peeking below the haze at different levels.
Exactly. And specifically on July 14th last year, they clearly saw cloud features lifting higher up. That was the real smoking gun for convection.
And JWST helped too.
Definitely. JWST provides incredibly detailed infrared data, complementing Keck. So between the two, they could measure cloud altitudes and track how they changed over days, even though they didn't directly see rain falling during these specific observation times.
That combination of ground and space observation sounds powerful. Okay, let's circle back to those northern lakes. How direct is the link between them and this convection they saw?
Well, the leading idea, the main theory, is that those big northern polar lakes are the primary source, pumping methane into the atmosphere through evaporation.
Makes sense, like giant puddles slowly drying up, but on a planetary scale.
Kind of, yeah. So detecting these rising cloud cells right above that lake region, it's strong support for that theory. It suggests that local evaporation from the lakes is directly feeding this weather system.
So the lakes are literally breathing methane into the sky, forming clouds.
That's a great way to put it. It really seems to be a direct surface-to-atmosphere connection driving the weather there.
That is profound. Now, you mentioned JWST also told us something about Titan's organic chemistry. How does that fit in with the weather?
Right, so JWST wasn't just looking at clouds. Its instruments are amazing for analyzing the composition of atmospheres. And it made a definitive detection of something called the methyl radical. That's Cu.
Methyl radical. Okay, what's significant about that?
Well, it forms when sunlight hits methane and breaks it apart. So UV light from the sun zaps the methane.
The same methane that's making the clouds and rain.
Exactly. And this methyl radical, this CEH, it's like a trigger. It kicks off a whole chain of chemical reactions that build up more complex organic molecules, like ethane, Ca.
So sunlight is breaking down the weather fuel, but also creating building blocks for other interesting chemicals.
Precisely. Which leads to another point Dr. Nixon made. He called methane a consumable.
A consumable, meaning it gets used up.
Yeah. If sunlight is constantly destroying methane, and it's forming these other heavier hydrocarbons that eventually maybe rain out and stay on the surface, then Titan needs a way to replenish that atmospheric methane over geological time.
Otherwise,
the methane could slowly deplete, maybe from underground reservoirs, cryovolcanoes. We don't fully know the source. But if it's not getting replenished sufficiently,
Titan could change drastically.
That's the implication. Nixon even speculated it could, over vast timescales, maybe become more like Mars, drier, less atmosphere, if that methane cycle breaks down. It really highlights how dynamic Titan might be, not just day-to-day with weather, but over millions, billions of years.
It puts the weather we see today into a much longer perspective. And speaking of changes, there's something coming up soon, right? An equinox.
Yes, May 2025. That's Titan's northern spring equinox. Just like on Earth, the equinox means the sun is directly over the equator.
And that matters because
it marks a major shift in how sunlight hits the moon. Energy distribution changes between the northern and southern hemispheres. Seasons change, just very slowly. A Titan year is almost 30 Earth years.
So this equinox could trigger big weather changes.
That's the prediction. Scientists expect potentially significant shifts in atmospheric circulation, maybe more dramatic weather events as the seasons turn. It's a key time to watch.
And we'll be watching.
Oh, yeah. There's actually a program at Keck called the Twilight Zone Program, specifically designed for long-term monitoring of planets like Titan. They'll be keeping a close eye on it through this whole transition period.
Okay, so we might be about to see some serious atmospheric action unfold, which brings up the big question. Why does all this matter to us back here on Earth? Why study methane clouds so far away?
It's a fair question. But studying Titan, it's not just about Titan. It gives us this incredible natural laboratory. Well, understanding how a nitrogen-rich atmosphere works with methane weather instead of water helps us build better models for planetary climates in general. It broadens our perspective beyond just Earth.
And maybe helps understand early Earth. Our atmosphere wasn't always like it is now.
Exactly. Plus, there's the organic chemistry we talked about. Titan is making complex organic molecules right now. It's not life, but it's happening in a non-Earth environment. Studying that could give us clues about how the building blocks of life might form elsewhere.
Or even how they might have formed here long ago.
Potentially, yes. So looking at Titan helps us piece together our own planet's past, understand climate better, and maybe even think about the potential for life beyond Earth. It connects back in some really fundamental ways.
So the big question driving the research is, will Titan stay this weird, cloudy, lake-filled world? Or is it heading towards something else?
That's definitely one of the huge questions, yeah. Understanding its present helps us predict its future.
It really is amazing thinking that methane clouds billions of miles away could hold secrets about our own origins, our planet's future. This convection discovery feels like a really important step.
It absolutely is. Seeing an active weather system driven by a different liquid, it just expands our whole idea of what's possible out there on other worlds.
It forces you to think beyond just water-based systems.
Right. It challenges that Earth-centric view. How many other ways can planets work? How diverse are these environments?
So if someone's listening and totally hooked on Titan now, where should they look to learn more as things develop?
We'll definitely keep an eye on results coming out from Keck, especially that Twilight Zone program as we go through the equinox. And of course, follow the discoveries from JWST. It's constantly revealing new things about atmospheric composition and surfaces across the solar system.
And maybe just dive into planetary science in general.
Absolutely. Planetary science, astrobiology. These fields are moving so fast right now. There's always something new and exciting coming out about the worlds in our solar system and way beyond.
It really leaves you wondering, doesn't it? What other unexpected connections, what other strange similarities might be hiding out there between Earth and these worlds that seem so alien at first glance?
That's the mystery, isn't it? What else is waiting to be discovered?
A fascinating thought to end on. Thanks for taking this deep dive with me today.